Hey everybody, today we're going to take a look at the AP Chemistry 2024 question 5. This is a sample walkthrough of the free response question. Quick disclaimer, belongs to College Board, not me. And so all credit for the questions goes to College Board. So let's start with question number, or part A. Write the equilibrium constant Kc for this reaction. So equilibrium constants, we always have products over reactants, right? And so with that in mind, we see that we have this lovely equation here. So we're going to have products, which is HI. And with this coefficient, with that stoichiometric coefficient, it becomes HI squared over H2 concentration times I2 concentration. And so that's all we need for part 1, where HI is a concentration of hydrogen iodide, H2 is a concentration of hydrogen gas, I2 is a concentration of iodine gas at equilibrium. Okay? So this I can even just write here equals Kc. You probably don't want to mess that up to get full points. Okay, now part B. At a certain time, the value of Q is 0.67. The following particle diagram is an incomplete representation of the system at this time. It shows a relative number, I'll highlight that, of H2 and I2, but the HI not included. Draw the number of HI molecules and then needed to complete the diagram. So that accurately represents the system. Okay, so this is Kc, but it also, like K and Q, like this can also represent Q. K is just at equilibrium, Q is obviously not at equilibrium. Or not obviously, but it's just not at equilibrium. So I'm gonna give myself some more space here. We'll do green for part B. So we have to make some situation where this equals our Q value of 0.67, and we're actually in luck because we have some numbers here that can help us out in this equation. So what we can do is we can have HI squared over I2. How many I's are there? There are 2 I's. And how many H's are there? There's 3 atoms, right? So this is 1 H2, this is 1 H2, this is 1 I2. That's why I put 2 here instead of each individual I, because we're looking for a concentration of I2, not just I. This equals 0.67. So this equates to 6. What's 6 times 0.67? Well, just 2/3 times 6 over 1 equals 12 over 3 equals 4. So we have HI, concentration of HI squared equals 4. Thus the concentration of HI equals 2. So we need to draw 2 HI molecules. So I'm going to draw my 1 HI molecule, and I'll fill it in on the exam. Obviously, you have to fill it in. I is bigger than H. And then here's my second. I don't think it really matters, like the relative location. Just make this obvious. So then we draw our 2 HI molecules. And then we are all set. So there are 2 molecules of HI when we have the Q value of 0.67. On to the next part. A student monitors the number of moles of HI over time. Hypothesize an experimental change. Use red for this question. That could have been applied in this rigid container. Okay, rigid key. V is constant. At time t, which I assume is that, yep, to change the number of moles shown in the graph. Assume the student did not add more gas. So just I'll rewrite. So it's I2 plus H2 equals HI. 2HI I should write. And we are given, I just noticed, we are given something here that's very important. We're given that the reaction is exothermic. Now, what does that mean? Well, that means that the reaction releases heat. So another way you can write this out is you can actually write plus heat. In the product side, you can treat heat as a product. And so what are we thinking when we see our equilibrium and we see heat? Well, I'm thinking that, wow, if we adjust temperature, we can actually adjust the products. Thinking back to Le Chatelier, if we increase heat, we're going to drive more of this. If we increase heat, increase this side of the equation, we'll drive this. But we see in this graph that we actually drive more HI. So from that, I'm thinking that if we decrease heat, if we decrease temperature, then we'll be able to shift the reaction more to the right side. We decrease this, the reaction will shift to the right. So my hypothesis, and that kind of, this is a good, I guess, assumption not to make, is that student decreases temp. Okay, and just to walk through again, when we have the exothermic, we can treat heat as a product because it releases heat. So if you decrease temperature, it'll go to the right. If you increase temperature, it'll go to the left, because increasing temperature would push that in that direction. Okay. So now, after equilibrium is established, the mixture is transferred to a larger container at a constant temperature. Okay, temperature, not messing with that. As a result, will the number of moles increase, decrease, remain the same? So, okay, larger container. Oh, larger container? What does that mean? That means larger volume. So I'm just going to make a note here. So I'll rewrite the equation. I2, H2, 2HI, and I'm really still thinking about Le Chatelier. These are all gases, which I can include. Are we told that HI is a gas? That's very important. We're told that HI is a gas. And so when you change the volume, that has an effect in terms of increasing or decreasing, or that can manipulate the number of gas molecules that will be in the system. If you decrease the volume, when we increase the volume, it will shift in the direction that increases the total number of gas molecules. Excuse me, when you increase the volume, you will increase the number of gas molecules. Why? Because that counteracts the decrease in pressure. If you increase pressure, it will go towards the side that doesn't have as many gas molecules. Let me reiterate that one more time. In this situation, the equilibrium will shift in the direction because the volume increases, the pressure, I should have written this earlier, decreases. The equilibrium will shift in the direction to increase the pressure to counteract this. In this case, we'll have 1 mole here of gas. We'll have 1 mole here, so products have 2 moles. Reactants have 2 moles, but the products also have 2 moles. So because of that, the number of moles will remain the same. And so I've kind of been talking to you guys all through my answers. And so I don't know if just writing just this would suffice on the exam, but really what you need to write down is that larger container means that pressure decreases, because we can think about PV equals nRT. We've seen this equation before. Pressure and volume are inversely related. And we know Le Chatelier is reactive to when pressure changes with these gases. And so when the container increases, pressure drops. We want to make more gas. However, in this case, the equilibrium can't shift to make more gas because there's 2 moles on both sides. Therefore, it'll remain the same. So that's all we have for question 5. I hope that was helpful. Please drop any comments or questions in the comment section. I will be uploading more of these AP chemistry and maybe all the AP free responses. So if there's a specific question that you'd like me to hit on, I'm happy to do so. All right, I'll catch you guys later.